Welcome back to CodinGame Summer Challenge 2024 Limbits. Let me just start the music. Okay, so yeah, so where are we? So I've started, so last time we did the hurdle race, one of 4 races, so I heavily focused on that. And it looks like we've got a good hurdle race thingy going. I mean, it's not better than what we had to beat Wood anyway, but the point is it's now comparable to the other games. So now we just got to implement the other games. So the easiest one is probably the archery one, so I should do that next. Just to get us closer to getting a better score. Also, I promoted to silver, so I guess I was near the top last time. I just needed a bit of time. So, and they've also opened the Gold League just recently. Cool. So what are we going to do about this archery? So if we look at these, let me look at each of these. So the hurdle race, the first 3 are player 1's position. The next 3 are the player's stuns. Here, okay, it's a bit different because here it's player 1, player 2, player 3, player 1, player 2, player 3. Here it's 1, 1, 2, 2, 3, 3. Here it's 1, 2, 3, 1, 2, 3. And here it's 1, 2, 3, 1, 2, 3. So it looks like we're going to have a bit of repetition here. So if I equals 0, looks like I just have to copy and paste this like 4 times, 3 times. And just modify it. Like, as much as I would like to, you know, make this functional, you have this weird exception, which is the archery one. Alright, we'll just do that. Let's remove these spaces so it's more compact. Also, zoom in a bit. So we're gonna take this. Elif I is 1, so we're doing archery. GPU equals game over. So the archery is just... Okay, we're gonna need a few things here. Okay, so we've got the... wind strengths. Should I just call it wind strengths? So we've got, so if it's game over, wind strengths equals none. My archery state, we'll call it archery state. Wait. Well, what is in an archery state? It's literally just the X and Y coordinates. Yeah. Oh, but you need to know what turn it is. Index. So there we do need a state. So we'll keep this notion of states. archery states. So in this case, the pauses is actually reg 0, reg 1. So you get 3 tuples. And then you got another tuple, which is reg 2. Hello, delta space. Reg 2, reg 3. Going for the gold league? I don't know. I don't know how hard it'll be. Let's say high silver. I don't think I'll have as much time to put into this as I have in some other competitions, because I'll probably be doing some other programming, some code jam. Not code jam. Game jam that someone else is organizing. So I'll aim for maybe high silver at best. How am I, if what I'm following, doing? Are you on, somewhere in the league? Okay, so you can go reg 4, reg 5. So that's the positions. So far. Archery state of was I. Oh, we don't actually know from this input what turn it is, so we have to infer it from... That's annoying. They don't tell us how many turns are left, you have to keep a counter. Oh! Oh no, I've misunderstood this. The current... In archery, the length of GPU is how many turns left. So this is the remainder. Ah, okay. So it's just... The last bit is always cut off. Oh, okay. Okay, good. So that... simplifies things. That means an archery state, we just need to know well, it still helps to know what position we're in, because a neighbor state where we make a move and move to the next state, we'd be further along, so that state would have a further index, so we do kind of need an index. So we still need to, but we don't need to, we know it's going to be index 0 when we fetch the input. All right, so the positions are those, I range 3. So we've got state equals archery state, given the position I and the index, which is going to be 0. We haven't made archery state yet. So if I use player, then we'll say my archery state is that. Otherwise, enemy archery states. It's that. Then we want archery. No, it's wind strength. Wind strength is that. Should we just say take first the X and the Y separately? So X, Y, index, those are the three properties of an archery state. That's all you need to know. Okay. This seems like such a long-winded way of populating this input. I don't know if there was a way I could have done this better, I don't know, because we're gonna have to copy and paste this chunk every time. The thing is, the first game, the third game, and the fourth game have the same form. It's like 1, 2, 3, 1, 2, 3. But then archery is the annoying exception, where it's 1, 1, 2, 2, 3, 3. So whatever, we'll just copy and paste this every time. I don't know if I even get past the archery game this stream. Well, it's gonna be really short because it's kind of simple. All right, so first we need an archery state. Okay, optimistic average turns. We can scrap that now, can't we? I'm not using that. All right, we want archery state. So we've got X, Y, index. See if that runs. Okay, so did you beat Bronze Boss without implementing other games? Yeah, apparently, yeah. I mean, at the end of last stream, I was in the top 5 or something, but it stabilized, so I guess it just sort of, over time, it seeped up. But yeah, I literally just optimizing the first game, and there's no code whatsoever doing anything with the other games. But I mean, my code for wood was already optimizing the hurdle game, so I don't understand why this was so much better. Oh, I think it's because once you get far enough ahead of them, then you're guaranteed to win. So there's no point doing optimal moves anymore. So at that point, my new code now does arbitrary moves because they yield the same score according to this scoring system. And the arbitrary moves are probably helping the other games somehow because it's less fixed or rigid. I don't know. For some reason, this is performing much better than my wood code, but I thought both were doing... Oh! No, my wood code was worse because it was trying to balance the 4 games, of course. But this is just trying to optimize the first game, so they are fundamentally different. Because there were 4 hurdles games, I forgot about that. Well, that was a really weird boss to beat in the wood league. I'm glad I don't have to deal with that anymore. Yeah, so yeah, it's just optimizing the first game, and then I happen to pick up a few silvers or whatever in the other games, which is enough. So let's see if we can just repeat the same for archery. My bot was promoted into the Gold League and I didn't implement the roller game because it's too random. So you can just pretend there are 3 games without roller. Yeah. Yeah, you can. Well, I mean, apparently you can do it with just hurdles as... Oh, sorry, Gold League. Oh, right. Oh, really? Yeah. That makes sense. I expect doing 3 games well would be enough, because you would pick up a few silvers anyway in the 4th game. And it'd be really hard to do well in all 4, so that's actually fairly valid. So you're not actually doing anything for the roller game at all. You're just letting it run arbitrarily. Yeah, I suppose you pick up a few points anyway. It's like it'll be a worry if you get 0, but that would only happen if the 2 people you're facing have both cared about the roller game. And I don't know if many people in silver do. I mean, I'm sure a lot do, but So get next states, right? So I want so for up, down, left, right, what do we want? We want a dictionary which maps the words up, down, left, right to the next states. That's basically what I did before, isn't it? Yeah. So, and this one's straightforward. It's just let's not try to be clever. Let's just write them out explicitly. Up. Result. And we can do this as a one-liner, to be honest. This is not that complicated. We just say up. I should stop using double quotes, just stick to one. I keep using different ones in different places. Okay, up maps to... Does this keep toggling me on or off? I swear I keep disappearing and reappearing. This bot seems a bit finicky. Alright, so it's fireworks. What's so many fireworks these days? I don't know what people are celebrating. And you know what? I don't want to do this as a one-liner. We'll just... index. And then it'll be index plus 1. In the R tree, when you go up, the Y should... Oh yeah, of course. Wait, is it? I mean, I know that's usually the case, but I thought in this particular case they had Y being the up direction. Just because of the way it looks on the... It isn't written in the rules, but is in the source code, fair enough. Yeah, I guess you can induce it from this. Well, I guess if I logged the... Alright, fine. I'll assume that's the case. So it'll be Y minus... So basically I have to just do this 4 times. So we could say down. Let's say the delta equals that. So then we want left. So that's wait, down will be plus. Left, it's going to be x minus delta. And then right plus so that gets the states. That's much simpler than this one for the hurdles. So that's the state. And okay, the index might run off the end of the list, but I don't think right now we're not doing anything that could cause that to happen. What, wind strengths? Wind strengths. Oh, because it could be none. Well, that's fine. Just don't worry about that. You need to clamp X and Y in them. Oh, of course. Huh. And alternatively, at the end, I could just cap everything to 20, but whatever. So max. So my archery score, that's just the overall score which we're fetching, my archery state, enemy archery states. This should be renamed to man, that's let's just add some line breaks here to make this a bit more readable. Okay. So now we need to populate those. All right, let's start with the scores. So up here, my hurdle score is that. Okay. So similarly, my archery score is 1, 2, 3, 4. It's 5. Yeah, okay. And then down here. Okay, so now we put these in here. We just, can I, my archery state, enemy archery states. Can we break these in the more sensible place? Turn count. So hurdle, hurdle, hurdle. Like that. Am I even allowed to do that? I think so, yeah. Okay. So this needs to be changed. We want okay, change this. So let's be more explicit with these points. This is expected hurdle points. And then we just do the same thing, really. So archery, if win strengths is where is it? Expected archery points is direction. Okay, so if it's game over, it's just shouldn't be 0. It should be whatever my current points are. No, it shouldn't be. It should... Hang on. We don't want to set it to 0 because it actually matters. Because ultimately we're going to multiply these 4 scores together. We're trying to improve the product, not trying to improve the individual scores. So we can't just put 0 here. What we want is the predicted... It's a game over, so it's a fresh game. We're not in the middle of any game. We want the predicted number of points. So basically you want to know... We need another method here. We'll just leave this like this. We need... like a method which says get number of points get expected number of points for all future games, knowing that there's 100 turns altogether and we are at turn so-and-so. So just do a straight up division. Like we know roughly, in some cases we know exactly how long the game is. In some cases we're just guessing because like hurdle depends on like how fast people go. So you just have to, I don't know, pretend they will go 2 spaces or something. That's not very accurate, but better than nothing. Oh man, this is confusing me. But we're already doing this here, so basically you have to just extrapolate that and, well, just extract that and put it into a method. Expected time remaining. All right, let's just make a bunch of methods then. So that's get expected hurdle points. Define get expected hurdle points for future games. For a given turn. So you would look at that turn, and that's the turn that a fresh game starts. And we would say time remaining would be something like this. Right. Okay, it's literally just that, isn't it? 99 minus self.turn count. So it's going to be, but not self.turn count, but turn. That's how many turns are remaining. And we want to divide by the average length of a turn. Now for hurdles, this is tricky. We said 30 here. Where did we get 30 from? And we did a float division because... But should we really be doing a float division? Because in the cases where... Probably shouldn't be doing a float division. Should be a strictly round down. Because you get no points for any incomplete games, so... Okay, where did I get 30 from? It was... I think I just looked at this and said, okay, that's 30 spaces wide or something, I don't know. Whatever, we'll just use 30. I think we need to have to add one for the game over screen as well. No. Well, you kind of... You can spend forever trying to make this accurate, so let's just say it'll be expected games remaining equals time remaining strictly divide by 30. Now you have to add one for the game over screen, but you don't add one for the final one, so it's like ask for it. Just do a float division. I can't be bothered to work out this out. So we say 30 plus 1 for the game over screen. In fact, I'll just write it 30 plus 1 to remind myself. don't even remember where. Yeah, 30 is the number space, and you've got to add one for the game over screen between. But you don't actually want to include the final game over screen. Doesn't matter. Return. Expected games remaining. Just assume we win silver in every game, so we get 1 point. No. It should actually be... No, we did this before. We said 4/3 is the average points. So it'll be 4/3 times 3 for gold, 1 for silver, 0 for bronze. So, with that method, we can now say expected future games points equals, oh my god, there's so many expected variables here. Everything from turn self dot. So it's going to be this plus this plus this. Plus 1. Because you've got the game over screen. If turn is greater than you could win a game on turn 99. Alright, if it's greater than 99, return 0. Okay, so remove that. Total expected points is expected points this game plus that. All right. Okay, but now the point of this was that we can now say if it's a game over right now, we'll just say direction maps to get. So it'd be self dot my hurdle score plus self dot get expected hurdle points for future games, starting from self dot turn count plus 1. All right, good enough. Otherwise, we actually get expected hurdle points. We shouldn't be adding the score here. That's something we do. Down here. Okay, fine. So if it's game over, we get that many points. We just predict that. Otherwise, we get the individual expected hurdle points for that state, and that includes all future games as well. So that's now expected hurdle points total for the whole game. This is expected final hurdle points. Like, I don't really want to call it, I don't want to keep extending these names, but that's that. Oh, actually, maybe we should. It's better to be explicit. Okay, so similarly, we can just do the same. It's gonna be new. Copy that, but it's gonna be a different name of the method. Get expected archery points for future games. Yeah, we'll have to make that method. Otherwise, archery points state plus the score. Okay. That's that. And then the remaining games will be similar. No. Okay. Should be archery. Neighbor states equals my archery state dot get next states. Okay. This is wrong. So then let's fill in these methods. So we've got get expected archery. Hello, Rezor. Do you know what would be optimal strategy for just archery game? Would it just be take whatever each turn, just take whatever your I don't know. It's a bit complicated when you have different wind strengths coming up. Yeah, because you can go past 0. That's what. If it were like, if you can't go past 0 in one turn, then it would be easy. You would just take whichever is the largest cardinal direction away from 0 and go towards 0 in that direction. But yeah, once you go past 0, it becomes a bit more of some sort of knapsack-ish kind of problem. I don't know. Yeah, you probably just have to be greedy and say. I mean, you could still pick whichever is your worst dimension and just go towards 0 in that dimension every turn. That's probably the best greedy. If you're doing only archery, I saw someone's strategy is to sort wind strengths and then assign directions to them. Sort. Like, is this some sort of knapsack algorithm? So you're trying to pair them up or something? Interesting. So you're trying to group them into... I sort of see where they're going with that, yeah. I'm probably not going to bother, but... yeah, it's like you want to separate them into two groups. And in each group you want the sum to be as close to 0 as well, including the original position. Yeah. Greedy till 7 rounds, and then for the last 7 rounds, just DFS the whole graph. Yeah? Sure. I mean, what's the branching factor? It's 4 to the power of, well, number of turns. Yeah, that should be fine. Okay. Four to the 7. Only 16,000. Yeah. Okay, so we need... okay, we need this method for archery. I suppose this one's easy, just expected archery points for future games. Expected games equals... so in this case it's going to be... how long is the archery? $12 to $15. Whatever, we'll just assume it's 13.5. 13.5 plus 1 for the game over. I'll just do similar to what I did before. Divide it as a float, return that. Okay. Damn it, I'm putting these in the wrong places. Stop. So these are all identical methods, it's just different expected lengths. Maybe I should... maybe we just say, maybe we just have one method. Expected game length. So here it's 30. So we just say seems like we could be using like some sort of enums system for archery and hurdle. So saying get expected points, future games, 30, magic numbers, whatever. Need a wider screen here. Zoom out a little bit just for now. 30, 13.5. Okay, so we've done that. Now we need this method. For archery. Get expected archery points given that I'm here and there's so-and-so number of turns left. Well, no, and that I'm in a certain index in the... Okay, so... This is where it involves a bit of maths, which I done earlier. So we want the differences between the two Euclidean distances. If we're saying we want the probability that player 1 beats player 2, then we want to take the difference between their Euclidean distances squared each. So you take the square distance of each of them, take the difference, and divide it by the square root of 20n over 3, where n is the number of games remaining. Where these numbers come from, I don't remember anymore. This is just how it worked out. 20 by 20, is that correct? 20n over 3. 20 is such a strange number. Don't remember where the number 20 came. What's better here, Euclidean distance or Manhattan distance? Well, it must be Euclidean distance. But how would you be using Manhattan distance? Like if Euclidean distance is the one which matters for the purpose of the scoring, then I don't see how the Manhattan use distance will be useful. Okay, so let me try and get all these variables I need. So we want the probability. All right, well, okay, fine. First, start with the simple bits. We need to know the x1, the x value and the y value of each player. So we need my x and y values, which are x1 equals archery state dot x dot x, x2 equals archery y1 state dot y. Then we need the next player, so that's going to be self dot enemy archery states 0. Dot x. Hello, Maro. We're doing some nerd stuff. I think I probably will be doing nerd stuff for the next few days. Not that any of my video games were not nerd stuff. I was just doing stupid Manhattans because it's a little easier to code. Do you find it easier? I mean, it's this very, very minor difference in easiness to code, I think. Okay, and then we want x3, y3. So we got x1, y1, x2, y2, x3, y3. What else do we need? We need n, which is the number of remaining turns. I just want the variables to match what I've written down here. So n equals... So it's going to be length of wind strengths minus archery state dot index. Yes. So now we want the probability of gold. Archery state, which is passed to this method, is it always the state of your bot? No, it's one of the 4 possible states I might arrive at after doing up, down, left, or right from my current state. So I'm trying to predict what that neighbor state, how good that neighbor state is, how many points I'm going to end up with from that neighbor state. But it belongs to your bot still. Yes, it should do. So I always try to put the prefix my on all the things which are unequivocally mine. Oh, I didn't do that in this case, but yeah, archery. Well, yeah, this could be used to predict. Yeah, it's a bit. So I would like to, in the future, maybe use this to predict the goodness of the enemy moves as well, but then that would kind of defy the fact that I've extracted me first and then the enemy's second. We'll worry about that. I don't think I'll even get to that stage. So yeah, we are basically assuming that this is me, my state, and not the enemy states. All right, this is where the mathsy stuff comes in. Now this was specially tuned to hurdle. So probability player at X turns from finish beats player at Y turns from finish. Let's just be clear. So now we need a new one for archery. Probability player at XY beats, so it's going to be beats player at X2, Y2 with N turns to go. So this is the most generic question we're trying to ask here. If I'm here, they're here, we've got N turns to go, everyone's just doing random moves. What's the probability I'm going to win? That's basically my measure of goodness. And it's going to be so the top half here is going to be if player 2 is further from 0 than I am, and we're just assuming the win strengths are random, then we're probably going to win with more than 50% chance. So yeah, we first take X X2 squared, or just do X2 times X2 plus Y2 times Y2. So that is the squared Euclidean distance minus X1 times X1 minus Y1 times Y1. So is this the right way around? Yes. If X2 and Y2 are bigger numbers, then this whole thing will be positive. And if they're bigger numbers, that means they're further away, they're probably going to lose. The normal distribution CDF of a positive number means the range, that means the kind of the area under the curve from that number all the way to negative infinity. So it's going to be strictly bigger than 50%, because the CDF of 0 is exactly 50%. In other words, if we were in equal positions, that would be straight up 0, and so we'd get 50%. So this all seems right-ish. And on the bottom we have this weird, okay, divide by, okay. So that's the numerator. And then on the bottom, it's math dot square root of 20. I say I'll have to redo the maths. I don't know if that 20 just seems like such a weird number. Times n divided by 3. n. What's O? With n turns to go. Yeah, with n turns to go, we have to provide n. Why are you not taking the square root of? Because I'm taking these norms squared. And why I'm doing that? I don't remember. That was just how the cumulative distribution function of this variable was derived. I'd have to redo all the maths to remember why, but this is just how it ended up. So I'll just assume this is what I've got for now, but yeah, my statistics is rusty, so I don't remember how to do these things, but I used some sources as well, which had already had a problem similar to this, so it looked like it matched the order of magnitude. So this... Okay. So if we've got that, we want... So n is that. Okay. Then probability of gold is the two independent... Oh, how long ago did the music stop? That keeps happening. Prox, archery, we want the probability that x1, y1 beats x2, y2, and we've got n. And then the independent probability, and now of course these aren't... Actually, this is independent for this archery, but for some games they're not truly independent. The skating is the worst example, because in this case, if you stand on the same square as someone, you're both stunned, so it no longer becomes independent. I think we'll just pretend that doesn't happen, because otherwise you're dealing with non-independent variables, and that's just makes things worse. Right, so we can independently work out the probability we beat player 2, multiply that by the probability that we beat player 3, and that's the probability we get gold. The probability we get bronze is probability that 2 beats 1 and 3 beats 1. Which is actually 1 minus this times 1 minus this. Doesn't really matter, we can recompute it. And then probability of silver is 1 minus that. So now we know the probability of getting gold, bronze, or silver this game. We can then estimate how many points we get for this game is going to be probability of gold times 3 plus probability of silver. That's linearity of expectation, one of the most important properties in statistics. Then we've got expected length this game. Okay, now it's not going to be that. So in the first game, the game ends as soon as someone hits the finish line. But here we know it's going to be n. Okay. I actually don't get the sorting strategy in archery. I think it's not intuitive, but there is, if I think the knapsack, the 0-1 knapsack problem, has a kind of like a polynomial algorithm for it where you sort first and then you do something with that, and I think that's sort of running in the same lines as that. I don't really know. I think the idea is if you've sorted them, then you can pair big with small, sort of in the way. Or take groups of them which are small and combine them to make a medium-sized thing. Right. So on the last two left. Yeah. I guess it's to do with groupings, and sorting it makes it easier to do that. So expected future games points equals yeah, I suppose in a way you are reducing the dimensions in that you have two independent dimensions and you're just popping items onto whichever one seems best at the time. Okay, so expected points for future games. So we don't want 30 here, we want 13.5. Return count, blah, blah, blah. Okay, is that everything? There's so much repetition here, but at the same time I can't really see a way of making this all really nice and functional, because there's lots of little exceptions here and there. So, we get okay, so now we've got expected final herder points and we've got expected final archery points. So so we say expected final points full stop is going to be a map which maps directions to that multiplied by that. Direction in, what did we call the variable? Directions? Yeah, we did, okay. So we're gonna say, if we go up, this is the entire final score of the entire game. If we go left, same. If we go right, same. If it goes down, same. We've got those 4 numbers. Now we just pick the best one. How do we do that again? We do best direction equals max amongst the keys, where our measure is lambda mapping k, the key, to the final points for that key. Okay, then we find the best direction. Let's put some logging here as well. Alright, now this could all go horribly wrong because I've not really tested any of this. But if it goes to plan, then we should be trying to balance game 1 and game 2 a bit. Delta is... Damn it, that's a character. Math.square roots 20 times... N is 0? Yeah, because we didn't take into account that if n is if we're on the final turn, we don't, then the state is a game over state. I don't even have a placeholder game over state. I just, let's say so where did it crash? Just skip all this. Okay, if n is 0, that means this probability doesn't make sense, but if it's 0, that means we already know how many points. Probably. Probability of gold is 1 if we are in the lead, and it's 0 otherwise, basically. If n is 0, probability of gold is 1 if so we want x1 times x1 plus y1 times y1 smaller than or equal to. The thing is, this doesn't take into account that the enemies have moved as well. Whatever, it doesn't matter. The enemies in this method, the enemies are still standing at their turn, their original space, and we've moved. That's not right. That's not exactly fair. We're being too optimistic. We have to assume the enemy has done a move as well. But I don't worry about that. Why not? We'll just replace n with n plus 0.01. What would happen then? Oh, so that'll make them a really big value, and that'll basically be... Yeah, that probably works. That's cool. Thanks for the raid, Garlips. This is, I'm guessing, very different to what you were doing. Were you doing Resident Evil? Racing? When's the actual race coming up? Yeah, Delta Space, I like your idea. I'm gonna do that instead of... So, if n equals 0, n plus equal... That's the beauty of the Gaussian distribution, isn't it? It's just like... It just covers all ranges. You can heal in here. How was your race? Did you give any more clues? Any humming clues for any new games? N plus equals 0 0.00. Let's just go with 0001. We're doing... I mean, the thing I'm coding right now is actually sort of... kind of like a kind of speedrun sort of thing where... You know those races that people have where... they're controlling several different games, but with one set of controls? Like... You might be playing Pokemon alongside... like Mario or something. But that would make less sense because Pokemon's turn-based and Mario is not turn-based, but sort of like that. That's basically what we're doing here. We have 4 different games, but we have one set of controls and it's just up, down, left, right. And they have different meanings in each of these games. You can actually see the visual impact here. We're trying to optimize all 4 games or balance them as best as we can, because our final score is the multiplication of our score for each of the 4 games multiplied together. So if you fail in one game and just get flat 0, then the final product is 0. So you can't afford to be disastrously bad in one game. Your best strategy is to try and be a bit good in every game. So we're trying to code this. It's pretty complicated, but at least to try and balance it. Each individual game, though, is kind of easy to optimize. The first game is like hurdles. So you can either run 1 space, 2 space, 3 space in one turn, or you can jump 2 spaces. So you want to jump over the hurdles, but otherwise you want to try and run as far as you can without running into a hurdle, because then you get stunned for 2 turns. So I mean, the optimal strategy is obvious if you're just playing that game alone. You just run as far as you can and jump over a hurdle. The archery one is just... Each turn you can press up, down, left or right to move your cursor in that direction, and you're trying to get it as close to the bullseye as you can. But the wind is different every turn, so if it's 5, then whatever you press, you're going to go 5 units in that direction. The third game is the most complicated one. That's I've not really focused on it too much. You're kind of racing, but if you go too fast, you fall over and get stunned for 2 turns, so you sort of balance your risk factor. And then the final game is kind of Dance Dance Revolution. You're trying to match up, down, left, right that's appearing here, but every time you fail, your combo resets to 0. So getting huge combos will get you huge points, but I mean, getting a combo means you're probably screwing up every other game, so... Yeah, they're wildly different, and it's really confusing trying to balance the 4. I'm about to run a piece of code which I think is actually trying the first and the second game, the hurdles and the archery, and dismissing the other 2. Just trying to get these errors sorted out. Get expected hurdle points. Okay, it's probably just a typo. So that's renamed. That's why it was underlined. Try again. No errors, okay, okay. 0 points because, right, how did we do, I mean, what matters here is how did we do in these first 2 games, so about at this point, we have 4 gold medals in hurdles and 4 gold medals in archery. And the interesting thing about the skating one is that no matter what you do, you occasionally pick up some medals in that, because it's just like... there's a lower risk, even though there's a thing that's literally called risk factor, but it doesn't impact you as much. The 4th game, however, if you choose not to do anything about the 4th game, then you will just straight up lose, because you get points for these combos. So if my combo is 1, I get 1 point that turn. Then next turn, my combo increases to 2, and you get 2 points. So far you've got 3 points altogether. And then the next turn, the combo goes to 3, so you get 3 points. So your total is 6. So your total points is actually going up quadratically. So if my opponents are putting in even the slightest bit of effort into that game and I'm not, then I'm not going to win by chance. So I guess that's what's happening here. But nevertheless, we are dominating the gold medals in hurdles and archery. But we're also balancing them. Like, I'd much rather have 5 gold medals in hurdles and 6 in archery than... oh, well, what is the final? Yeah, it was 5 in hurdles, 6 in archery. Yeah, I'd rather have that than like 2 in hurdles and 9 in archery, because it's the product, and the product is optimized when they're all equal. Kind of like how the area of a square is bigger than the area of a rectangle whose lengths are equivalently summed, or something like that. Alright, well anyway, this stream I implemented archery. We've got archery. It made our overall rank worse because I'm now getting 0s, but it's still closer to what I want this program to be. Okay, so I guess next time I will implement it doesn't make sense to do racing next. Like, if the one I'm failing on now is dance, let's call it diving, because it's actually diving, is diving, then I think next time I should do diving. Oh, there's one more thing. I need to modify the formula for the hurdles. Hello, I think for bronze and silver you have a better chance to know how good your score can be if you play against others and not the bosses. That is true, yeah. Let's do that. I actually forgot that these were bosses. I thought these were people. Let's just try these 2 people. Alright, we'll try this again. We'll see what happens now. Yeah, it makes sense because the bosses are quite... what's the word? Degenerate? Like that's like the mathematical term for when you do things which are like things that are not like have zero probability of happening normally. Like you wouldn't normally expect them to happen. Did I? Oh, same conditions. That it means same bosses. So I have to do that, I guess. That is a good point, and it might mean I stand a better chance. Okay, well, in that case, let's submit it. Let's just try one more. I'm not going to get zeros, yeah, because the bosses are weird. I mean, that's what's going to happen if you have the same AI for both bosses. There's no real way to avoid that. Like, you could have them have a lot of RNG in what they choose, but that has its own issues. Get 0 for that one. But, I mean, it didn't exactly do much worse than positive quarks, so not terrible. What am I losing? It's diving. That's... okay, let's submit it. Oh, but I actually wanted to fix the formula as well. Okay, we'll let it run. So... I want to redo this. Where is it? This formula here. So instead of that, all right, so the thing about this is it doesn't use the stun time. And it should, because the stun time matters. So the new formula with stun time would have WX, WY. WX is the number of turns you have to wait before you can move again. WY is the number of turns you have to wait. And if you have those, and they can be, what, 0, 1, or 2, then how this changes would be... Right, so the numerator is going to be that divided by 2 plus WY minus WX. That's the numerator. And the denominator. So that factor of 2 is being transferred from the bottom. So this actually ends up looking like... it's just simpler if I move that 2 up. Math dot square root. Oh, that stays the same. Yeah, okay, x plus y over 8. So yeah, just put in the wait time as well. Slight adjustment. I don't think this is going to change my rank or anything. It probably will, but not by much. Let's make sure we're using that now. Okay, so... okay, take that out. That was my hack that I had before. I didn't mathematically justify that, I just threw it in there, so we'll take that out. So my stun state. Tell you what, let's just say Wx equals Wz okay. All right, so that's Wx, Wy. Wx, Wz. Y, X, Wy, Wx. Wz, Wx. Everything else should remain the same. Minimum of x, y, z, y by 2. We should actually throw in the wait times. Plus Wx, because you've got to wait that many turns. Plus Wy. Plus Wz. Right. Let's try again. See what if it changes anything. If we're not doing anything about diving, then it probably won't. But you can see if it improves our first 2 games. Changes the outcome, but I didn't really keep track of what I had the first 2 games. All right, well. He's got a lot of wins in diving. Interesting. Okay, so yeah. Hello, Saint Pope 42. If you get at 1 game only bronze medal, you will get only 0 at score. Yeah, if you don't get any golds or silvers, yeah, that's true. So you need to win. Yeah, you need to, get some gold or silver in at least one of the games. And the biggest issue for me is the diving game, because if you don't do anything about that, you just straight up lose. But the skating game, it seems I always pick up golds randomly because there's less variance. If you do random picks, you can still actually, seems like you do somewhat decently. But yeah, the diving you need to actually do something about. And the diving is the trickiest concept here because you've got this combo thing. Which my approach with this CDF thing may not be suitable for diving because you kind of want to pick a stretch, and for that stretch just get the combo for like, I don't know, 3 or 4 maybe to get you nice big points, and then for the rest you don't care, do you? So you could do something like that, but But, I mean, now I'm starting to realize how it's useful to do what... who was it that was... Delta Space was mentioning about the sorting idea, but the point being that if you look ahead at all the next 10 turns or something and plan out it becomes more of an assignment problem than a probability balancing problem, but that might actually be better. The sorting was for the archery, but yeah, I'm just saying the idea of planning ahead is interesting here, because then you can make an assignment for each of the next 10 turns of what you're going to do. But it only really works for how much you know, so you have to see which game has the shortest known foreseeable future, and that's really how much you know. Oh, it's difficult. This is a difficult one overall. Did I submit this? Just test this and then submit it. And that will play a bigger role for the diving, because diving you do kind of want to set aside a run. The problem with this probability thing is it's just going to assume you have a 1 in 4 chance each turn of losing your combo. In other words, you basically lose your combo every turn. But that's far from what would happen if you just choose to force the combo for like 3 or 4 turns. So in that case, the probability thing is not a good estimation at all. But the other ones is, because like in the first game you always move roughly 1, 2, 3 or 2 turns. Even if you get stunned, okay, you're set back for 2 turns, but on average you're always moving about a turn per turn. It's fine. Same for the other 2 games, really. Yeah, okay, let's just submit this. And then I think I'm probably done for today. But that was to the guys these guys just got promoted, so. Okay, so let's just wait for this and then. But I mean, okay, so I think the next stream I'll sort of just finish off this line of this whole thing. So just do the same for games 3 and 4. Probability distribution, like make whatever simplifying assumptions I need to make it work and make it be just a simple normal distribution thingy. Then just literally just do this thing here. Just pick the one which has the highest expected points, and then at that point, if I still have time left, I can just overhaul it and do something completely different. Oh, how time flies. Because I'm probably gonna be doing that game jam starting, is it starting tomorrow? I think it is. So, yeah. I mean, I like what I'm seeing with what we've done so far. So there's hope that if I just finish this off, then it could qualify for gold. Somebody said at the beginning of my stream that they did qualify for gold just by doing games 1, 2, and 4 alone. Who said that? Oh, it was Delta Space. Yeah, so yeah, so that's where I'm going to set my goal. Just make it to the Gold League. Probably not much higher than the bottom of the Gold League, though. one of the devs for the site stopped by my stream yesterday, so that was cool. Clement. Oh, we're only like 25% progress, so maybe I'll just finish. Let's have a look at the big leaderboard then. Full leaderboard. Oh, I'm catching up to Ku. That should just be my target. Every one of these tournaments, try and overtake Ku. But I know that Ku likes to spend a lot of time on these. I don't normally assign as much time as I did in the first couple of tournaments I did. One potential strategy to balance 1 and 4 would be to go dive when you can, and then if a hurdle is in front, go hurdle no matter what. You will not sprint the fastest, but you will never get stunned by the hurdle. Yeah, I'm starting to see the pitfalls of this probability approach. It can only take me so far, so we'll just have to see what the result is when I provide it, because it doesn't... The Gaussian distribution simplifies everything to a mean and a variance. When you know the mean of your moves and the variance of your moves, then you get a Gaussian distribution. That's what the central limit theorem says. But of course, it's a big simplifying assumption, and it doesn't hold well for small values of n. And these are small values of n. So if hurdle is at one distance, go up. If not, go whatever dive tells. I'll keep that in mind. I might need to throw in some overriding code which is specifically aimed at throwing all these probability things out of the window and just focusing on dive under certain conditions, and then otherwise fall back to the probability thing, something like that. Yeah, the maths is confusing the heck out of me. I don't need to do any more because I already have the formulae for the last 2 games that I want to implement. But the problem with game 3 is it doesn't even use the risk factor in the formula, because the risk factor is... I don't know what to do about that. You can't really simplify that. You have to do a whole Markov chain to describe the transitions between different risk states and stuff. So it's going to be a really simple formula, which is literally just my distance subtract their distance divided by root n, where n is the number of turns left. It's so simple that I'm worried that it's just going to be quite bad, but seeing as we already pick up points in the racing game, maybe it won't be that bad. I'm not doing this strategy myself at the moment, so I don't know how useful this would be. Yeah. So are you guys in... You can feel free to drop your CodinGame username in chat if you want to me to add you on the leaderboard here so that my viewers appear in the list here. Okay, it looks like I've basically somewhat reached league opening June 21st. Cool. Kreska. How do we do this again? Is it friends? Are these the same user? Was it Kreska with a capital K? There's the smaller K. Why do they make them separate? Capitalization shouldn't be separate users. Wait, no, was it the Wait, was the capital K? This one, okay. Will I stream tomorrow? Yeah, I'll try to, and I might try to do it earlier. I keep saying that, and I end up not doing so. But today I specifically extended my Airbnb just so I'd have more time to do this uninterrupted. So I'm staying at my current flat like a week longer. Sorry, Delta Space. So it looks like capitals matter. Okay, Delta Space. There we go. But yeah, I will try to stream tomorrow, and ideally earlier, which will be more in the afternoon for me. Because I will also probably be doing the game jam at some point, and I don't know when that's happening. Okay, so yeah. Poland and Russia. And I am from England. Let's see how many from how do you do this? Let's just do full leaderboard. So I am in the UK. I am position, what's that, like 20 or something? But I'm not in the UK right now. I'm in Vietnam, so maybe I should do Vietnam. That might give me a better rank. I should just fly to the most remote country. Whoa! No, I'm not top. I am... Oh wow, some pretty good Vietnamese coders here. I am, what, 5th? But, okay, 5th. All right, I think I'll just leave it there then. It looks like that's roughly my final rank. Anyone streaming? No, they never are. Nobody's ever using this thing anymore. Okay, well then I guess I'm not raiding anyone. Unless... Should we just have a look on Twitch? Maybe somebody's doing CodinGame. No, nobody's doing it. I'm just streaming at a weird time. All right, that's it then. I'm not going to stream a video game, and that's just feels a bit weird if this is a coding stream. So I'll just stop. Thanks for watching, and hopefully see you tomorrow. Bye bye.